There are a lot of really scary places in our universe, and most of them are cold worlds where life could never arise. But even among all this dark variety, there are objects that we can call the most dangerous exoplanets we've discovered. And now I propose we go to the most incredible one of all. In 2020, just before Halloween, NASA compiled a list of the scariest worlds, including 6 exoplanets. Each one is an object that not only has extreme conditions for any living organism, but even being near it can be fatal. The first of these was a gas giant called TRES-2b. This celestial body orbits the star TRES-2, a yellow dwarf located 718 light-years away from us. TRES-2b has a unique surface chemistry that allows the planet to absorb more than 99% of the light falling on it. The reason for these features is not yet known, and there may be chemical reactions going on in this celestial body that we have not been able to detect with any similar object before, and they are what make TRES-2b the darkest exoplanet we know. This gas giant was discovered on August 21, 2006, and more detailed characteristics were obtained a few years later. TRES-2b has a mass of 1.2 Jupiter masses and a radius of 1.27 Jupiter radii. The planet's atmosphere is heated to 1,000 degrees Celsius, causing the exoplanet to emit a faint red glow that looks like glowing coal. Despite all its gloomy appearance, TRES-2b cannot be called the most dangerous place in our universe. In addition, there are many more scary objects hidden in space. It is an exoplanet called 55 Cancri 1, located in the system of the Sun-like star 55 Cancri He. This celestial body was discovered on August 30th, 2004, using Doppler spectroscopy. This planet has a mass approximately equal to 8 Earth masses and a radius of 1875 Earth masses. 55 Cancer 1 is in an ascending lock, so it never dawns on one side of the planet and never gets dark on the other. Therefore, the side facing the star is always heated to plus 2,400 degrees Celsius, while the temperature of the night side is plus 1,300 degrees Celsius. Such a large number can be explained by the fact that the planet's distance from the star is only 183 tenths of thousands of astronomical units. In addition, the planet likely has volcanism, which regularly ejects dust clouds that prevent heat production. A day on this planet lasts just under 18 hours, and the atmosphere contains helium and hydrogen. It also contains a high proportion of carbon, which likely forms thick layers of graphite and diamond in the planet's interior. However, 55 Cancer 1 is not the only object in the planetary system of its star, because in addition to it, there are 4 other celestial bodies. All of them have much more favorable conditions, and it is this fact that distinguishes the 55 Cancer home system from the next item. This is called Poltergeist, or PSR 1257 plus 12c, and it's an exoplanet located in the Pulsar system. This object is only 0.36 AU from the center of the system, and it shows that Poltergeist could not have survived the supernova explosion that probably preceded the pulsar. Thus, the exoplanet could have formed after this event, for example, from amorphous material formed after the explosion. There is another hypothesis, according to which a pulsar can be formed by the merger of 2 white dwarfs. And this process is not often accompanied by a loud explosion. But since this is the first time we have observed such objects, science still doesn't know the exact answer to their origin. The celestial body system is located 2,300 light-years away from Earth, and by mass, Poltergeist is about 4 times more massive than our planet. It has a rotation period of about 66 days. In addition, if we ever get close to this mysterious object, the radiation streams emitted by the pulsar would likely destroy all spacecraft. Given all these features, Poltergeist cannot be called the most dangerous exoplanet we know. In fact, if a small space body, when approaching it, can simply collapse, then in close contact with the next object, it will completely vaporize. The reason for this is the extremely high temperature of Kepler 70b, the hottest exoplanet known to us. This object orbits the dwarf star Kepler 70. The surface temperature here is higher than our Sun and is 6,800 degrees Celsius. The object has a mass of 0.44 Earth masses and a radius of 0.76 Earth masses. The rotation period of this celestial body is 345 minutes, so the day here lasts less than 6 hours. At the same time, the exoplanet regularly passes by another object of the system, Kepler 70c, at a distance of 240,000 kilometers, and it is now the closest planetary transit we have been able to record. The extremely high temperature of this celestial body can be explained by the fact that this object may have once been part of its parent object. However, the final recognition of Kepler 70b exoplanet is currently an open question. It is worth noting that Kepler 70b is not the only celestial body known to us, so closely interacting with its parent star. Another object in similar circumstances is an exoplanet called WASP-12b, or WASP-12b. This celestial body is 870 light-years away from our system. Its radius is 1.93 times larger than Jupiter, and its mass is 1.46 times the mass of the solar system's largest planet. WASP-12b is 0.03 AU away from its star. Because of this close coexistence, the temperature of WASP-12b reaches 2,200 degrees Celsius. And due to the extremely strong gravity of the parent star, the star will gradually absorb this celestial body, and in about 10 million years, the exoplanet is likely to completely disintegrate. Given all these circumstances, it is unlikely that we will be able to delve deeper into the study of this planet. Such worlds do not seem to be of primary interest to science. However, some of them have truly unique properties, and despite their appearance, harbor much more danger than meets the eye. For example, when you fly past HD 189733b, you might think it's a safe planet because it looks a lot like our Earth. But as they descend into its atmosphere, each passenger faces several deadly dangers. The winds here are made up of silicate particles and have a speed of 8,700 kilometers per hour. In addition, the exoplanet is experiencing rains that cause precipitation of molten glass to fall on the surface. The main reason for such deadly weather is the extremely high temperature and composition of the atmosphere. An exoplanet's orbital period around a star is about 2.5 days, and most likely, the planet is always facing the star in the other direction. In terms of its properties, HD 189733b is a light blue gas giant in the constellation of Foxy. Its distance from our system is only 63 light-years, and the diameter of this object is 1/10 of the diameter of Jupiter. The mass of the exoplanet is 13% more than the mass of the largest planet in our system, orbiting the orange dwarf. The distance between HD 189733b and its star is 30 times smaller than the distance between Earth and the Sun, and is about 5 million kilometers. Due to this proximity, the exoplanet maintains a constant temperature of about 930 degrees on the bright side and does not drop below 425 degrees on the dark side. The first studies of this object began immediately after its discovery. And in 2007, using Hubble data, scientists discovered that HD 189733b has a hazy atmosphere. Also, when the planet is between an observer on Earth and the star, its atmosphere takes on a reddish hue. The possible cause of this effect is atmospheric fog, which, according to preliminary estimates, consists of iron particles, silicates, and aluminum oxide. In addition, scientists were able to confirm the presence of water vapor, neutral oxygen, and the organic compound methane in the planet's atmosphere using Hubble data. And after a second study, the presence of carbon monoxide on the day side was confirmed. However, the greatest number of questions caused the research. according to which in the atmosphere of the planet were found traces of methane, which is in a special fluorescent state, emitting electromagnetic radiation in the EC range. This state of matter suggests the presence of unknown activity in the atmosphere of HD 189733b, which has yet to be unraveled. Thus, thanks to the study of this object, we can conclude that even on the most uninhabitable exoplanets can still occur processes that are of interest to science. And while the process of their research will continue, such worlds will long remain only horror planets for us and always remind us of how lucky we are to have our Earth. The universe is full of countless other worlds. Of the thousands of exoplanets discovered beyond our solar system, none could be considered more hospitable to us than Earth. Some are melting from the unbearable heat of nearby stars. Others are forever encased in ice or burned by destructive radiation. But among the many unfriendly worlds, there are some very different ones. On their surface, oceans swirl and rivers flow, clouds float across the sky, and the atmosphere is full of torrential rain and thunder. Perhaps these worlds could become the cradle of beautiful and unique life as Earth once was. And today, we'll move on to the most important of them all, space. It can hardly be denied that life is one of the most marvelous, complex, and mysterious phenomena in the universe. Although we have studied it for millennia, many important questions about it remain unanswered. And most importantly, how widespread is biological life beyond our planet? At present, it is impossible to say with certainty whether the Earth's biosphere is a unique phenomenon or whether it arose as a natural result of long evolution. It is not surprising that the search for life beyond Earth is one of the most important scientific directions. And in this regard, the so-called Earth Similarity Index, or ESI, was developed to identify the most promising celestial bodies. It's based on two basic parameters. This is the level of gravity on the surface of a celestial body and its equilibrium temperature. According to researchers, these parameters determine how much another world can be similar to the Earth and how favorable the conditions on its surface are for hypothetical life. The undeniable advantage of the ESI is its simplicity. When an exoplanet is discovered, you can usually determine its approximate orbit, mass, and size, and this information is only enough to calculate the basic parameters of the index. However, while attractive, it does not take into account many factors important for sustaining life. We are therefore developing our ESI-based evaluation system and augmenting it with several important parameters. One of them is the action of the parent star. It is known that the recurring eruptions and stellar matter emissions characteristic of red dwarfs can negatively affect the atmospheric stability and radiation background of nearby exoplanets. However, red dwarfs are considered more favorable than large stars such as Sirius or Vega because the life of giant stars is too short and the radiation is too destructive, leaving room for the possible development of life. Orange and yellow dwarfs, including our Sun, are considered the most beautiful. Another important factor can be considered the probability of tidal locking, which depends on the distance between the exoplanet and the star. Celestial bodies that are too close to the star are constantly rotating in the other direction. Therefore, there is a large temperature difference between their day and night sides. Too great a distance from a source of heat and light takes a planet out of the habitable zone, drastically reducing its habitability. It is also necessary to consider the type and chemical composition of the exoplanet. After all, the development of hypothetical life requires a certain set of chemical elements combined with a characteristic topography. Stony Earth-type planets, or super-Earths, can provide similar conditions, while mini-Neptunes lack solid surfaces, and ocean planets are deficient in many elements. Thus, the set of parameters we have collected allows us to comprehensively assess how favorable the conditions on the selected exoplanet are for hypothetical life. For example, the Earth on such a scheme will look extremely attractive, being a natural benchmark for other objects. At the same time, Mars, although it has the highest index of similarity to our planet in the entire solar system, has a number of obvious disadvantages. It is too cold and has a low mass, and also has a serious shortage of water. Despite appearances, Venus is too hot due to a strong greenhouse effect. And although most of its parameters are in the green zone, the extremely high temperature is a critical disadvantage of the planet, negating all its advantages. So there are not enough Earth-type planets in the solar system to be considered suitable for life. However, beyond its borders, in the vicinity of distant stars, already discovered worlds more than 5,000 years old, some of which in many ways can be considered similar to ours. One of the closest such objects is an exoplanet known as Gliese 1002b. Located just 15.2 light-years away from our planet, it was discovered in 2022 using the radial velocity method. This method is effective for finding relatively close exoplanets by recording the subtle oscillations of the parent star caused by the motion of space objects around it. The exoplanet is located near a small, dim red dwarf known as Gliese 1002. Its radius is only 14% of the Sun's, and its mass is 8 times smaller than that of our star. Given that Gliese 1002's surface temperature is only 3,000 Kelvin, or about 2,730 degrees Celsius, it's not surprising that its luminosity is extremely low, about 700 times less than the Sun's. Observations also show that the object is characterized by a very quiet character, uncommon for stars of this class. Due to the low brightness of this red dwarf, its habitable zone has an extremely small radius and width. However, the object Gliese 1002b is located near its outer edge and can be considered potentially habitable. According to observations, this celestial body makes a complete revolution around the center of the system for about 10 Earth days, from which it follows that the average radius of its orbit is very small and is about 0.46 astronomical units. It is hypothesized that because of its extreme proximity to the parent luminary, the exoplanet is likely in a tidal grip and is permanently turned to one side of it. Calculations show that the celestial body receives from its star 1.5 times less energy than the Earth from the Sun, and the average temperature of its surface can be approximately 230 Kelvin or minus 43 degrees Celsius, which is slightly warmer than Mars. Taking into account tidal capture and a possible greenhouse effect, this means that liquid water could be found on the exoplanet's surface, and thus conditions for sustaining life. At least some terrestrial organisms are able to survive in such conditions. Also, calculations show that the mass of Gliese 1002b is 8% greater than that of our planet, and its radius exceeds Earth's by only 3%. With this information, it is easy to determine the acceleration of gravity on the surface of the celestial body. It's pretty much the same as the value we're used to. So, the combination of all the factors we know suggests that Gliese 1002b is a rocky planet, most of which is covered in ice. It has a fairly high ESI of 0.86 because of its size, close to Earth. In our diagram, this object looks like this. Meanwhile, modeling of the planet's climate shows that its illuminated hemisphere can absorb enough energy to support a liquid ocean with archipelagos, or even full-scale continents. At the same time, tidal deformations coming from the side of the nearest star heat the planet's interior, so the existence of an ocean hidden under the ice, even on its night side, cannot be ruled out. Moreover, Gliese 1002b is not the only planet in the system. At the same time, an object called Gliese 1002c was found to be a little farther away, namely 0.074 AU from the center. This exoplanet has an annual cycle of 21 days, and its mass exceeds that of Earth by about 36%. The object receives 4 times less energy from its parent star than our planet receives from the Sun, so its surface temperature is quite low at about 182 Kelvin or minus 91 degrees Celsius. If we use the previously developed scheme, the exoplanet will look like this. It can be assumed that the conditions on the surface of Gliese 1002c, are close to those observed on the satellites of Jupiter or Saturn. Increased volcanic activity caused by the high mass of the planet could be the cause of a hidden ocean with warm and salty water saturated with many chemical compounds. Hypothetically, life could also arise in such conditions, perhaps in highly unusual and unexpected forms. Of course, among the many known exoplanets, there are many warmer and more beautiful worlds. This is, for example, the planet K272e, which is 217 light-years away from us. It orbits a small red dwarf about 4 times the size of our star. Its radius is 0.33 times larger than the Sun, and its temperature is relatively low at 3,360 Kelvin, or about 3,100 degrees Celsius. Observations by the Kepler orbiting telescope have shown that an exoplanet crosses the disk of its parent star every 24 days. This means that the radius of its orbit is very small and is on the order of 0.1 astronomical units, which implies that the celestial body is located within the habitable zone and can be considered potentially viable. The findings also suggest that K272 may be in tidal capture or Mercury-like orbital resonance. Despite the star's low luminosity, the exoplanet receives 11% more energy than Earth receives from the Sun. Assuming K272i's atmosphere is similar to Earth's, the average temperature at its surface should be about 295 Kelvin or 22 degrees Celsius, which is slightly warmer than our planet. It is worth remembering that if the celestial body is in a tidal grip, there is a high probability of extreme temperature differences between the day and night hemispheres. In addition, it is worth considering that its parent luminary, like most other red dwarfs, is characterized by an erratic nature and often demonstrates flares and large emissions of stellar matter, which can have a detrimental effect on the atmosphere and surface of nearby space objects. Meanwhile, calculations show that K272i is 29% larger in diameter than Earth and about 2.2 times more massive than it. Knowing this, we can calculate the level of gravity on the surface of this celestial body. It is about 32% higher than what we are used to. Thus, combining all known data, we can assume that this exoplanet, with a high probability, is a rocky super-Earth, on which liquid water and a dense atmosphere can be found. It has a fairly high similarity index of 0.87, and our diagram shows these objects looking like this. Planets of this type are expected to have a wide variety of chemical elements and a flat topography favorable to life. Undoubtedly, the frequent flares of a nearby star pose a serious threat to the atmosphere. However, a strong magnetic field could hypothetically guide stellar wind particles, and the oceans could protect its inhabitants from harmful radiation. If this is the case, it is conceivable that K272i could display incredible auroras, much more spectacular than those on our planet. As for the hypothetical biosphere that could develop on such a planet, it is likely to be markedly different from Earth's. A different spectrum of incident light may force local plants to use alternative substances for photosynthesis, so their leaves are likely to have a purple or reddish color. In addition, excessive radiation hazards could limit life's landfall or lead to the evolutionary formation of defenses, such as thick skin or specific cellular structures. Similar features are also known in terrestrial organisms, such as the pacifers, archaea, and some fungi. Meanwhile, in addition to this attractive planet in many ways, 3 others have been discovered in the system. 2 of them, called K272b and K272c, are very close to the parent star and slightly larger than our planet. Because of the radiation and stellar wind from a nearby star, they are assumed to be devoid of an atmosphere and similar to Mercury. The third planet, K272d, is estimated to be comparable to Earth, with an orbital radius of approximately 0.08 AU. It makes a complete revolution around the center of the system in about 15 days and is near the inner edge of the habitable zone. Because of its high temperature, the conditions on its surface are likely close to those of Venus, and the likelihood of life forming is very low. Either way, this system is still being explored, which means we have a lot to learn about it in the future. That said, all of the objects we studied were comparable in size to Earth, but for all we know, life can adapt to a wide variety of conditions, including the high gravity that is unavoidable on massive planets. When we move about 1,800 light-years away from the solar system, we can detect a yellow dwarf with parameters very similar to our star. The star, called Kepler 452, is a main sequence star that is only 3.7% more massive and 11% larger than the Sun. In 2015, a very significant exoplanet called Kepler 452b was discovered near this star by a transit method. Using high-precision measurements, we were able to calculate that it is located at a distance of 1.04 AU from the center of the system and makes its annual revolution in 385 days. This position makes the probability of a celestial body being captured by tides very low, which is certainly a favorable factor. Kepler 452b is reportedly about 5 times more massive than our planet and has a radius about 1.5 times larger than Earth's. This means that the gravitational acceleration on the surface of this celestial body is 2.2 times what we are used to. Such a high level of gravity likely helps the planet hold a dense atmosphere and also smooths out its topography, which could be the cause of many shallow and warm seas. It is believed that these are the conditions most favorable for the potential origin of life, but for humans, such a significant attraction would be extremely uncomfortable. It is also known that Kepler 452b receives 10% more energy from its parent star than Earth does from the Sun, and is in its habitable zone. Calculations show that the average surface temperature of the object is about 300 Kelvin, or plus 27 degrees Celsius, which is 11 degrees more than our planet. So the climate of Kepler 452b could be close to what it was in the Mesozoic. However, with a certain composition of the atmosphere, such temperatures can be dangerous and lead to the acceleration of the irreversible greenhouse effect up to the complete evaporation of the oceans. According to some hypotheses, this is the process that radically changed the appearance of Venus several billion years ago. From the combination of all the factors we know, we can assume that Kepler 452b is most likely a rocky super-Earth rich in a wide variety of elements and minerals. It is assumed that because of the increased content of radioactive elements, planets of this type should demonstrate increased volcanic and tectonic activity and high gravity to prevent the emergence of extremely high mountains and deep faults. At the same time, the ratio of land to ocean on the surface of Kepler 452b must be different than on Earth. Consequently, this exoplanet with a high probability can represent a boundless ocean dotted with a scattering of archipelagos. If we take our minds off the dry numbers and try to imagine what life might look like on this amazing planet, so similar to Earth and yet so different from it in many ways, we are faced with a truly fantastic sight. The abundance of shallow, warm seas probably allows us to expect a wide variety of aquatic life forms, from the smallest to the very impressive. As for terrestrial creatures, they are likely to be represented by stocky trees with thick trunks and stocky herbaceous plants. Due to the fact that the spectrum of the parent luminary in this system is close to the solar, the color of photosynthetic parts of local plants is likely to be familiar to us, green or bluish. Various small animals with strong bones and strong muscles can also be seen. Another evolutionary pathway is exoskeletonized creatures, such as terrestrial kinistopods. When it comes to flying creatures, exobiologists are divided. Some believe that high gravity is an insurmountable obstacle to flight. Others believe that the decisive positive factor in this matter is the high density of the atmosphere. In any case, we have several more years of research ahead of us before we can say with certainty that this planet is indeed habitable. Every year, we discover hundreds of new exoplanets. Some are downright rude and even dangerous. Others are much like Earth in many ways. But no matter how much we observe other worlds, we still can't reach them.